Okay, so let's start week 9 lecture. Now in week 9, we are going to see stored program control. This is very interesting and this is related with the third type of switching system, which is the electronic switching system. Okay, which is the electronic switching system. So, so far we have seen the manual switching system, we have seen the Stroger switching system, then we have seen the crossbar switching system. Now we are going to shift to the electronic switching system, which is the core of the switching system of today's life, whichever we are using in today's day-to-day communication. So the core of electronic switching is stored program control. So we are going to see that in today's class. So what is stored program control? Now you can actually assume what is stored program control by its name itself. So something will be stored, okay, some data will be stored, and there will be program control. So it is almost related with some data saving or data memory and some software control or programming. We can actually get that from this name. Now in stored program control, we have stored data on the processor, okay, or stored program on the processor. So there will be a memory, there will be a processor. So on the memory, there will be some program saved, and there will be instructions that will be programmed. Okay, so there will be instructions are programmed, and there will be control functions. So all these are the elements of stored program control. So in our today's switching systems, we must have this memory to save the program, processor to run or execute the instructions, and also to send different control signals and operate different control functions. So these are the elements of stored program control, or the main core of electronic switching. Now, in stored program control, or SPC, SPC means that a computer program stored in memory, it is used to control the operations of a telephone exchange or switching system. Instead of using hardwired logic like old electromechanical switches, SPC uses a processor and software to make decisions like who is calling whom, how to set up the connection, how to manage timing, billing, and call routing. Think of it like using a small computer to manage all the tasks of the telephone switch instead of using mechanical parts or fixed parts or fixed circuits. Now switching, so there is a small example, okay, explaining the SPC. I'm skipping this. So modern telecommunication networks still use the core principle of SPC. Now in today's life, we are actually using SPC, but in more modernized manner. Okay, in modernized manner. In more, however, the hardware and software are far more powerful, and architecture has evolved. Okay, how they have evolved? So more processors, or more, they are more AI driven in today's life. So it is the foundation of all current switching systems, implemented in more powerful and abstract forms. Now, you can say that in old days, switching was like manually changing train tracks. Now with SPC, it became like using software to automatically control track changes. That means track changes means the switching. So the switching will be now happening. Now it will be happen like automatic. Okay, it will be done automatically by the software. So now it's like using an AI-driven system that plans the best route in real time and can event change, tracks, mid-journey, all done in the cloud. So this is the switching system what we are using in today's life. Okay. Now, in old days, this type of switching was done. Now, with time, this switching system was evolved to electronic switching system with SPC. Then the SPC, with SPC, we have done or we have add more flexible switching systems, especially in the cloud. The switching system all are done in the cloud. So all these are, added with SPC for the current days. Okay. So this is the total, evolution of the switching system from past days to the current days. Okay. Now, so, you can get the idea that why SPC is important for us to study or to understand. Now, the generation of switching system, the first generation was manual switching system. The second generation was Strowger and crossbar switching system. The third generation is electronic switching system, which is done on the principle of stored program control. Okay. Now, it is a set of instructions called program are stored in its memory. These instructions are executed automatically one by one by the processor. Features of stored program control like dialing, call forwarding, call waiting, etc. All these are done by this stored program control. So stored program control is a telecommunication technology used for telephone exchanges controlled by a computer program stored in the memory of the switching system. So basically, when a caller is, calling a number, so what is the function of switching system? To establish a path between the calling subscriber and call subscriber. So in SPC, all these are, being done by the program control. Okay, all of these are being done by the they are all of these are done automatically. You have saved a program that if this caller is calling this number, this is how you have to select the route. This is how you have to connect them. Then you have to start the counter, for bill generation. So this is so whole process are saved by a program. Okay, by a program or coding. So all these process are being instructed before they are done. They are saved at the computer before the processing. So all of the instructions and how to do, what to do, all are instructed by programs and saved in the processor. Okay. Now the basic control structure of an SPC telephony exchange. So in a SPC telephony exchange, it can control the trunk control. It can also, it is connected with the line control. It is connected with the ancillary control, maintenance control. So all these functions are actually controlled by the SPC exchange. Now, the SPC exchange can be classified into centralized SPC and distributed SPC. Now, what is a centralized SPC? So in centralized SPC exchanges and used in a single processor to perform the exchange functions. Currently, centralized exchanges use dual processor for high reliability. So basically in a centralized SPC, the central processor is responsible for taking all the decisions. Okay, so all of the other elements will be sending the data to the centralized processor, the main processor, and the processor will take the decision that which task should be done by whom and how. Okay. So in centralized SPC, all the control equipment is replaced by a single processor. Okay, that single processor will be the main controller. So it must be able to processing 10 to 100 calls per second, the organization of a typical centralized SPC. Okay, so basically, all the main functions will be done by a central processor. Okay, now we can see there is a processor and there are connections from lines. Okay, there are connections from lines. So this is our input lines. So we are going to scan the instructions. Then it will be sent to the processor. Then there is a connection from the processor to the signal distributor to the outlines. Okay, to the outlines or to the called subscribers. Then the processor will be also controlling the maintenance, the memory, the secondary storage like call recording, program storage, etc. So it operates in various modes like standby mode, load sharing mode, synchronous duplex mode. So let's see the three modes one by one. So standby mode. In this mode, two processors are present. Okay, so there will be two processors. One processor is active and the other is in the standby mode. So if active processor is fail, then use standby processor. So there will be two processor. So basically one processor will be doing all the functions and the other processor will be in standby mode. Okay. Now if the main processor fails for any uncertainties, then the standby mode or the standby processor will be doing the functions. Okay. Now this is the block diagram of standby mode. So it is the active processor, it is the standby processor. So all of them, both of them are connected with the exchange environment and both of them are connected with the secondary storage. So whenever this active processor is not in action or it fails, so standby processor will be on action. Okay. Now synchronous duplex mode. So there will be two processors. So in this mode, hardware coupling is provided between two processors. So there are two processors and two processors will be active at the same time. So these two processors which execute same set of instructions and compare the results continuously. So two processors P1 and P2 are connected and separate memories like M1 and M2. So if you see the block diagram, so there are two processors P1 and P2, both of them are connected with different memories. So there is M1, there is M2 and there is a comparator. Okay, so both of them are actually doing the functions and their results are actually compared in the comparator. So any kind of discrepancies will be handled in this case, and we can get that by the output of the comparator. So one of the processor actually controls the exchange, but other is synchronized. When one processor is taken out, then the other processor operates independently. So there are three cases in comparator. Continue with both processors, take out the active processor and continue with the other. Continue with active processor but remove other processor from the service. So this can be done from the output of the comparator. Okay, so there are three cases. Okay, now in load sharing mode. In load sharing mode, both processors are simultaneously active. These processors share the resources of the exchange and load. So there are two processors, P1 and P2, both have different memories like M1 and M2, but both the processors are simultaneously active. These processors share the resources of the exchange and load. Okay, now in case one of the processor fails, the other one takes over the entire load of the exchange with the help of exclusion device. So there is an exclusion device ED. Now when one processor fails, so other will take over the entire load. Okay. Now we have seen the centralized SPC. Now we will see the distributed SPC. So in distributed SPC, it is more reliable than centralized SPC. Why? Because in centralized SPC, all the decisions are taken by a central processor, and there is a problem of overhead connections, like there will be a loading there will be a loading, or there will be a dependency on the central processor. So all the commands needs to be sent to the central processor. Then from the central processor, the signal should be sent to the particular element. So this is how you have to send signal and receive signal. So there is too much signaling. Okay, so there is too much signaling in centralized SPC. Now in distributed SPC, it uses low cost microprocessors. So if we see the block diagram of a distributed SPC, so this is the exchange environment. That means the users, okay, users from which from the users we are going to receive different signals. So from the exchange environment, EM means event monitoring. It is represented by EM. Distribution processor DP, call processor CP, operation O, maintenance processor MP. Okay, so with this exchange environment, all these elements are connected, and all these elements are connected with each other as well. So all of them can now take decisions from their self. Okay, so this is the main difference between the central processor and distributed processor. Now these are different levels of this distributed SPC. So in level 1, there is operation and maintenance processor. In level 2, there is call processor. In level 3, there is event monitoring and distribution processor. So we are going to see in which level which tasks are being done. So in level 1 is responsible for handling the following operations: bill charging, bill distributing, monitor traffic, customer support, making a new service, disconnecting a requested service, etc. Okay, so these are done by this operation and maintenance processor. Then there is level 2, call processing. So level 1 process like bill generation of a consumer. Meanwhile, if exchange is assigned a new level 2 process like call connecting, then processor will currently pause the level 1 process and will continue level 2 process. That means call connecting will be in process. After completing level 2 process, it will resume level 1 process. So next, go to the level 3. So in level 3, event monitoring and distribution processor will be working. So in level 3, processing will include functions like scanning, distribution, controlling all incoming and outgoing local calls, STD calls, ISD calls, fax, and data services. So all these functions will be done by the event monitoring and distribution processor. So this is the block diagram of a exchange control function, the SPC, which is the switching part with processor. So this is the inlet users, this is the outlet users. So from the inlet users, there can be different SPC, like you can go to, there can be different routes actually. So you can go to from this switching part to this switching part. Okay, you can go to this switching part to this switching part to connect this user, or you can go to this switching part to this, to this for connecting this user. So there can be different combinations and different routes. Okay, now SPC software can be of two types, system software and application software. So system software means there will be system software that will deal with different system softwares, and there will be application softwares, like application software deals with switching software, administrative software, and maintenance software. Okay, so now the advantages of SPC. Now if you compare with the previous switching systems like manual switching systems and crossbar switching system or Strowger exchange, then SPC is more easy to control, it is easy to maintain, and it is flexible. Okay, so these are the advantages of SPC. Now I will take few questions from you.